Hi all. In this video, we are going to learn about linear regression. Before starting linear regression, we will first see what a linear equation is. It is nothing but the statement of equality of two mathematical expressions involving one or more variables is known as an equation. An equation in which the highest power of the variable is always 1 is known as a linear equation. The one below is a linear equation. Here m is the slope and b is the y-intercept of the line. X and y are variables. For each and every value of x, there is one y value based on a linear equation. In this diagram, we are actually seeing one same linear line with a formula. Let's assume our linear equation is y equals m multiplied by x plus c. Also, assume m is equal to 0.7 and c is equal to 2.3. Now I am going to give a value to x from 0 to 10. This is how y is varying with respect to x. So that we will get one line if we connect all points. Now we are moving forward to linear regression. Let's dive deep into it. A linear regression is the reverse of what we did earlier. We have to find the m and c values so that the line that we get will have a lower cost function value. We clearly see the cost function. Don't worry about that if you don't know now. In real life, the purpose of linear regression is to find a real number with respect to the input variable x. Here we collected a few data points for x and y. We need to find the line so that we can find the value of y with respect to x so that it satisfies the above pattern. First, we randomly initialize the m and c values. Here we have one line, and you can see it's not correct. Still, we can optimize the line. Now that this green line is looking perfect, this is what we are looking for. So how can we get this? How do we find a linear equation so that predicted y is near actual y along the line? Well, cost functions and gradient descent algorithms playing major role for this. There are a lot of loss functions available. But we stick with the mean square error. Below is the mean squared error equation. MSE is equal to 1 divided by the summation of actual y minus predicted y for the whole square. N is nothing but the number data points that you have for training. Here we see how the loss function reacts with respect to the w value. Here, w is nothing but m. Here we have to notice one thing, b is 0. First, we assume b is equal to 0 and w is equal to 1. If I give like that, my predicted y value is exactly equal to my actual y value. So that loss function is 0. Now, similarly, I am changing w values like 0.5 and 0, respectively, and I am getting some loss function values. If I do that, I will get a curve like what you are seeing on your right side. From this diagram, one thing is clear, we have to choose perfect m and c values so that our equation has a lower loss function. Is it possible for you to image the relational diagram between weights and loss functions in 3D? Don't think much, let's see what it looks like. I hope you noticed one thing, we just put the m and c values randomly to get the previous curve. But actually, it is not a scenario. We will initialize our weights only once. Each and every iteration, we change weights until we reach the optimal point where the loss function is less. Who's playing a major role here? Well, that is gradient descent. We see a basic gradient descent algorithm. Gradient descent is nothing but updating weight parameters with respect to each iteration. First, we initialized w. Using the below formula, we updated the weight value. Here, alpha is nothing but learning rate. This may play a major role, which we will discuss in another video. Just take a look at this picture. Here I am showing how the rate of change of cost functions with respect to weight changes sign. This is nothing, but I differentiated j with respect to w and b. If we do it continuously, we will get the optimum line that figures out the pattern behind the data. Using that line, if we get an x value, we can predict the y value. That's it. I hope you enjoyed this video. Thanks for watching.